a daring experiment to transform a distant, icy dwarf planet into a cradle of life. In the year 2185, Earth's greatest minds and hearts converge on a singular purpose: to turn Ceres, a cold, desolate world in the asteroid belt, into a vibrant, living planet. It began with a vision born of necessity and hope, a promise that mankind was destined to spread beyond the confines of Earth, to create new homes among the stars. Deep in space, massive orbital mirrors are unfurled into position, their surfaces glistening as they capture and redirect sunlight onto the frozen crust of Ceres. These mirrors, engineered with precision and powered by advanced composite materials, slowly warm the surface, initiating a controlled thaw. Their rotation and tilt are orchestrated by computer algorithms that track the planet's rotation and solar position, ensuring that every region receives just the right dose of warmth. This meticulous calibration sparks the sublimation of ancient ice, releasing water vapor that will eventually condense into vast reservoirs. At the heart of this transformation lies Project Ceres, a multifaceted terraforming initiative that marries cutting-edge fusion energy, robotic engineering, and ecological design. From Earth, a fleet of fusion-powered cargo vessels departed, laden with modules that would serve as the backbone of the new civilization. These vessels, guided by both human expertise and artificial intelligence, traveled across millions of kilometers to deposit vital equipment in orbit around Ceres. Their cargo included atmospheric processors, water extraction units, habitat modules, and the first generation of robotic laborers, all destined to work in harmony on this grand experiment. Upon arrival, the first phase of the operation began. Massive fusion reactors installed in secure orbital platforms ignited with controlled bursts of plasma. Their steady hum provided the energy needed to power every facet of the terraforming process. The reactors drove atmospheric generators that began releasing a carefully engineered blend of greenhouse gases into Ceres's thin exosphere. This blend was designed to trap the newly directed heat from the orbital mirrors, gradually building a warmer, denser atmosphere. As days turned into weeks, the first hints of a nascent climate emerged on the dwarf planet's surface. In the early days of terraforming, automated drones scurried across the barren landscape. These robotic units, sleek and efficient, performed tasks that ranged from laying the groundwork for water reservoirs to installing sensors that continuously relayed data back to the central command center, Nucleus 1. From within this high-tech nerve center, scientists and engineers monitored every detail: temperature fluctuations, atmospheric composition, and even the initial patterns of vapor condensation. Their work was relentless and precise, a constant effort to balance rapid transformation with the need for a stable, sustainable environment. At T+30 days, the first environmental domes were activated. These early biodomes, designed as controlled enclaves of life, housed the initial cadre of colonists, a hand-picked group of 500 scientists, engineers, and explorers whose mission was to not only survive on Ceres, but to nurture its rebirth. Inside these domes, artificial gravity was generated by slow, controlled rotation. The living modules were engineered to simulate 1G conditions through centrifugal force, spinning at 2.3 rotations per minute to mimic Earth's gravity. In these habitats, the colonists began to adapt to a new way of life, one where every step was taken with the knowledge that they were part of something far greater than themselves. Beyond the domes, robotic units continued their tireless work. They laid down networks of conduits for water and power, constructed weather stations, and even began the first experiments in biological seeding. Genetically engineered plants, known as Ceres bloom, were released into controlled outdoor areas. These plants, with their deep chlorophyll-rich hues and enhanced metabolic pathways, were designed to thrive in low-gravity, low-pressure conditions. Their primary purpose was to convert carbon dioxide into oxygen, slowly thickening the atmosphere while providing a foothold for future ecological succession. As the first month passed, Project Ceres entered a crucial stage: the establishment of a nascent hydrological cycle. The heat provided by the fusion reactors and orbital mirrors melted vast quantities of subsurface ice. The resulting water vapor condensed high in the atmosphere, and then, almost miraculously, light rains began to fall. These early showers, though sporadic, signaled the birth of a water cycle that would eventually sculpt rivers, lakes, and even primitive seas across Ceres' rugged surface. Robotic aqueducts and water filtration systems were deployed to capture and store this precious resource, ensuring that every drop was accounted for and used to nourish the developing biosphere. In parallel, the colony's command center, Nucleus 1, operated as a bustling hub of activity and innovation. Within its walls, holographic displays projected real-time data from hundreds of sensors scattered across the planet. Here, engineers adjusted the orientation of orbital mirrors, fine-tuned the output of atmospheric processors, and monitored the fusion reactor's steady cadence. Every adjustment, every calculation, was a piece of a vast, interlocking puzzle, the puzzle of transforming an inert, lifeless rock into a thriving, habitable world. The leadership of Project Ceresspace was a blend of technocracy and democratic consultation, where every colonist's input was valued and every breakthrough celebrated as a shared victory. The colonist population, carefully managed from the outset, grew steadily under strict guidelines designed to maintain genetic diversity and social balance. Every birth was a milestone, celebrated with ceremonies that connected the new life to both Earth's legacy and the promise of Ceres. Educational programs were integrated into daily life, with children taught not only the science behind terraforming, but also the cultural heritage of Earth, and the ethical imperatives of nurturing a new world. In this way, the colony was not just a technological experiment, it was the beginning of an entirely new society, one built on the ideals of collaboration, sustainability, and hope. Within the rotating habitat rings, the human experience took on a surreal quality. Mornings were marked by the gentle, artificial sunrise created by carefully calibrated light panels, while evenings were celebrated with communal gatherings under domed skies. In these shared spaces, the colonists recounted stories of Earth, its blue oceans, green forests, and bustling cities, while also dreaming aloud about the future of their new home. Art, music, and literature flourished in this unique environment, drawing inspiration from the stark contrasts of Ceres' red-brown regolith and the vivid hues of engineered vegetation. It was a culture in the making, one that honored the past while daring to reinvent the future. Yet the journey was not without its challenges. The low gravity of Ceres, while offering opportunities for innovative architecture and lifestyle, also posed significant physiological challenges. Medical teams worked around the clock to monitor the health of the colonists, employing advanced biometric sensors and personalized exercise regimens to combat muscle atrophy and bone density loss. Specialized clinics were established within every habitat ring, equipped with state-of-the-art diagnostic tools and staffed by physicians trained in off-world medicine. Every day the colonists engaged in routines designed to simulate Earth-like physical exertion, resistance training, rotational exercises, and even simulated gravity walks, to ensure that their bodies adapted safely to the new conditions. In the face of such adversity, the human spirit shone brightly. Every setback, a temporary failure of an atmospheric processor here, a brief interruption in the fusion reactor's output there, was met with swift, innovative solutions. Teams of engineers and scientists collaborated seamlessly with robotic units, their combined efforts ensuring that no challenge remained insurmountable. This dynamic synergy between human creativity and mechanical precision became the hallmark of Project Ceresspace, a constant reminder that the future of Ceres was built on the foundations of resilience, ingenuity, and unwavering determination. Amid this whirlwind of activity, the cosmic theater provided a stunning backdrop. Ceres, once an obscure, lifeless remnant of the early solar system, now became a canvas upon which humanity painted its grandest dreams. The orbital mirrors, like colossal metallic petals, refracted the light of the distant sun, creating an ever-changing play of shadows and illumination across the terraformed surface. The colonists, when they looked up from their daily tasks, saw not the barren void of space but a tapestry of potential, a universe that had shifted, even if imperceptibly, to accommodate the spark of life that now burned on Ceres. Communication with Earth, though challenged by the vast distances, remained a vital lifeline. Quantum entanglement relay stations and laser-based data networks ensured that messages traveled almost instantaneously between the two worlds. Every transmission from Earth carried updates of familiar landscapes and the echo of a shared past, a reminder that even as they forged a new identity on Ceres, the colonists remained forever connected to their ancestral home. These exchanges, often filled with nostalgia and wonder, bolstered the colonists' resolve to continue their transformative work. A network of satellites and ground-based sensors, collectively known as the Gaia node, formed the nervous system of the terraforming ecosystem. This colossal orbital platform, positioned strategically above Ceres, synthesized data from hundreds of devices scattered across the planet's surface. With near-instantaneous processing capabilities, the Gaia node orchestrated every aspect of the terraforming process, from modulating the output of the atmospheric processors to adjusting the precise angle of the orbital mirrors. It was the silent guardian of the project, ensuring that every parameter was meticulously controlled, every fluctuation accounted for. Scientific breakthroughs emerged at a rapid pace within this pioneering environment. Researchers on Ceres developed innovative methods for synthesizing nutrient-rich soil from the mineral-dense regolith. They harnessed techniques to extract and purify water from melted ice and even discovered novel ways to recycle every drop, ensuring that the water supply would be both abundant and sustainable. Simultaneously, breakthroughs in genetic engineering allowed biologists to create flora uniquely adapted to Ceres's low gravity and thin atmosphere. These resilient organisms not only began to green the barren landscape, but also started the slow process of converting carbon dioxide into breathable oxygen, a process that would eventually give rise to a self-sustaining ecosystem. Daily life on Ceres became a harmonious blend of technological marvels and timeless human traditions. Colonists awoke to simulated dawns, their senses gradually stirred by the gentle glow of light panels designed to mimic the natural progression of a sunrise. Work in the habitat rings was punctuated by moments of quiet reflection in communal gardens and interactive classrooms, where every individual was both a learner and a contributor to the ongoing story of terraforming. In these spaces, the boundaries between work and play blurred, as families, friends, and colleagues gathered to celebrate each small victory. A new patch of greenery, the successful calibration of a reactor, or the birth of a child destined to inherit the legacy of Ceres. The culture that emerged was as diverse as it was vibrant. In Nucleus 1, public forums and holographic assemblies were common, where colonists discussed everything from technical updates to philosophical questions about their role in the cosmos. Intellectual debates were as frequent as musical performances, and murals depicting Earth's ancient beauty intermingled with futuristic visions of a terraformed paradise. Every art installation, every song composed to the steady hum of fusion reactors, was a testament to a collective spirit that refused to be confined by the limitations of a once barren world. The governance and economy of the colony evolved in parallel with its physical transformation. A council composed of representatives from science, engineering, agriculture, healthcare, and culture met regularly to discuss policies, allocate resources, and plan for future expansion. Trade networks, both within the colony and with Earth, thrived on secure digital channels, ensuring that goods, ideas, and capital flowed freely. In this dynamic ecosystem, innovation was not only encouraged, but was essential. Startups and research labs flourished, driven by the shared goal of refining every aspect of the terraforming process and laying the foundation for a thriving, independent society. Yet, even as Project Ceresspace advanced with impressive momentum, the colonists remained ever mindful of the cosmic forces beyond. Ceres, despite its burgeoning beauty, was still subject to the whims of space weather. Solar radiation, cosmic rays, and micrometeoroid impacts loomed as constant hazards. In response, engineers deployed an array of automated defense systems, laser arrays that deflected incoming debris, electromagnetic shields that dispersed high-energy particles, and self-repairing surface coatings that mended any damage incurred. These safeguards, operating in perfect concert with the terraforming infrastructure, ensured that the delicate progress of ecological transformation was never compromised by the harshness of the interplanetary environment. In the midst of these grand technical endeavors, the human element remained central. Every colonist, whether tending to the engineered gardens, monitoring sensor arrays, or operating the robotic units, became a steward of a legacy that transcended individual ambition. Their personal stories intertwined with the larger narrative of Ceres' rebirth. Families celebrated milestones with grand festivals. The first unhelmeted walk on the newly terraformed surface was marked by collective cheers and tearful embraces, and every new birth was seen as a beacon of hope, a living reminder that the future was being written in the dust and ice of an alien world. As the decades passed, the transformation of Ceres accelerated. By the fifth year, atmospheric pressure had risen to a level where designated regions allowed for unassisted breathing. The once sporadic rains became part of a predictable, gentle cycle that nourished engineered ecosystems and allowed water to carve gentle channels across the planet's surface. New settlements sprouted along these watercourses, clusters of biodomes and rotating habitat rings that expanded the boundaries of human civilization on Ceres. The engineered vegetation matured into sprawling groves of Ceres bloom, their leaves shimmering under the refracted light of the orbital mirrors, while rivers formed from melted ice meandered through valleys, promising a future where natural landscapes would coexist with human ingenuity. Robotic assistants, ever present and ever reliable, became partners in every facet of daily life. Their synthetic voices and efficient, graceful movements were a common sight in both workspaces and communal areas. They helped maintain the intricate balance of the terraforming systems and provided support during moments of crisis, when sudden dust storms whipped across the surface or when minor glitches in the fusion reactors threatened to disrupt operations. These machines, integrated with sophisticated AI, were the unsung heroes of Project Ceres, ensuring that every aspect of the transformation proceeded without a hitch. Interwoven with the technical progress were moments of quiet introspection and cultural reflection. At Nucleus 1, colonists gathered to view holographic archives of Earth's lost wonders, images of blue oceans, vast forests, and bustling cities. These sessions were bittersweet, a reminder of what had been sacrificed and what was being built anew, yet they also served as an inspiration, fueling the determination of every Ceran to honor the legacy of their home planet while boldly stepping into an uncharted future. Philosophical debates on ethics, identity, and the meaning of progress became as integral to the colony as engineering schematics and sensor data. As the terraforming project approached its midterm milestone, the focus shifted from radical transformation to delicate stabilization. Advanced atmospheric processors, now upgraded with next-generation AI, operated with a precision that could predict and counteract even the most minute fluctuations in environmental conditions. The once frenetic pace of change gave way to a measured, steady progression, a slow and deliberate nurturing of Ceres into a self-sustaining world. This phase, known as Project Equilibrium, was a testament to the intricate interplay of technology and nature. Every sensor reading, every data point, contributed to a vast tapestry of information that informed subtle adjustments, ensuring that the hard-won gains of the first decades would be preserved for generations to come. In these moments of reflection, the leaders of Project Ceres often spoke of legacy. They envisioned a future where Ceres would not merely be a colony or an experiment, but a vibrant, autonomous planet, a beacon of human ingenuity that would inspire further exploration and innovation. The Council's vision extended beyond mere survival. It was a call to create a society in which science, art, and philosophy coalesced into a harmonious existence, where every inhabitant was both a guardian of the past and an architect of the future. In the waning light of 2185, as the transformed landscapes of Ceres glowed softly under the reflected radiance of the sun, the colonists gathered for one final grand commemoration. At a specially constructed amphitheater within Nucleus 1, leaders, scientists, engineers, and families came together to celebrate the culmination of decades of toil and the promise of what lay ahead. Holographic projections recounted the epic journey, from the initial launch of fusion vessels from Earth, through the painstaking assembly of orbital mirrors, to the triumphant unveiling of verdant oases amid red-brown plains. Speeches, interlaced with music inspired by the hum of reactors and the whisper of wind through engineered groves, resonated with a deep collective pride. Every detail of this journey, The precise alignment of orbital mirrors, the rhythmic pulse of fusion reactors, the silent diligence of robotic units, and the unwavering spirit of the colonists, had woven together to create a new chapter in human history. It was a narrative not just of survival, but of transformation and rebirth. In that grand moment, under the gentle glow of the artificial twilight, humanity on Ceres affirmed its commitment to continue pushing the boundaries of what was possible, knowing that their efforts would echo through the cosmos for generations to come. This is the story of Ceres in the year 2185, a story of transformation, resilience, and the timeless human quest to create life where there was once only desolation. It is a testament to our capacity to reshape the universe through vision, determination, and a boundless belief in the future. As the terraforming project draws ever closer to completion, every river that flows, every green patch that flourishes, and every breath taken in the newly enriched atmosphere stands as a tribute to the legacy of Project Ceresspace, a legacy that will forever illuminate the dark expanses of space and remind us that no frontier is too remote, no challenge too great, and no star too distant for the human spirit to conquer. In the silent twilight of this reborn world, as the gentle hum of fusion reactors underscores the rhythm of life, the people of Ceres gaze upward toward the infinite tapestry of stars. They carry with them the memories of Earth and the dreams of a future unbound by the limits of the past. The terraforming of Ceres in the year 2185 is more than an engineering feat. It is a declaration of hope, a beacon for all who dare to dream beyond the familiar shores of home. And so, under the watchful eyes of a transformed cosmos, humanity on Ceres embarks on the next chapter of its journey, ever ready to face new challenges and to embrace the boundless possibilities of a future written among the stars.